This is the graphing tool Desmos at desmos.com. It's a free online graphing calculator, and it's just, you can type kind of natural math into it. So I'm going to say f of x equals x cubed, because that's the function we've been playing with. And I can say x and then sub 1, so I press the underscore key and then a 1 and then hit tab to get out of the subscript, equals 5. And I can do something similar with x sub 2, let's say that's 6. And I can say show the point x sub 1 comma f of x sub 1, and it should put a point on the graph, but I don't see anything because the function is way up off the top of the screen at x equals 5. You can zoom out by just putting your mouse here and hitting your scroll wheel, but I want to keep 5 on the screen there. You can scroll just the x or y axis. If you're using a touch screen, you can just pinch and zoom. If you're using a mouse, you can put your mouse near the axis you want to zoom. Hold down Shift. You see how the cursor changed to an up-down arrow, and you can scroll that way, or run your scroll wheel, and that'll help zoom. All right, and then we'll put another labeled point x sub 2 comma f of x sub 2. And now we want to know what's the rate of change of the function between those 2 points. And we've been calling that a difference quotient, and it is. But if I try to type FDQ, Desmos gets all confused with having more than one variable name right all in a row. Let's call it m, because it's a slope, it's a rate of change. And that is y2 minus y1 over x2 minus x1, or we could say f of x2 minus f of x1 divided by x2 minus x1. So difference of the y's divided by difference of the x's. And we get 91, which is what we had gotten before. And now the fun part is I can grab this point and say I want x2 to be closer to x1, and I can watch what happens to the slope here, the slope of the line between those 2 points. So if I have 5.1 and 5, then my estimated slope is 76.51, which matches what we had in Excel. And now if I want to get this even closer, I have to zoom in. And grab it. Funny that x cubed is a curved line, but once I've zoomed in enough, it looks pretty darn linear. And if I bring this down to 5.01, can't quite get there, but pretty close. I'm getting something like 75.13-ish, which is about what we had there. I can even bring this back below and use a negative delta x value, and I'm getting a slope that's 74.8-ish. So that's Desmos, and both in Excel and Desmos, we want to let this delta x go to 0 without actually being 0 to get an estimate of the rate of change of the function at time 5, not just from time 5 to time 6 or from time 5 to 5.1. And we want to have some way of saying what number should go here without having to try a bunch of different values, without having to try to eyeball it. And that's where the power of algebra is going to help us in the next video.